Hello, I will introduce Task-Aware Semantic Map++, cost-efficient task assignment with advanced benchmark. Let's get started. If a map provides only object labels or location data, it is difficult for a robot to figure out actionable tasks on its own. To address this, we introduce tasks as a new layer of semantic information in the map. First, let's look at the framework overview. The input to our framework consists of RGB images, depth maps, and camera poses. First, we use these inputs to perform 3D instance segmentation, obtaining object segmentation entities. Next, we apply mask refinement to correct noisy segments for each object. Then, we proceed to select the views that best represent the object state. During this process, we filter out views where the object is only partially captured, or significantly occluded. Moving on to the task assignment phase. Based on the previous view selection, we select up to 8 views in sequential order, and stitch them together. Additionally, we incorporate a predefined task set and task criteria into the prompt. We have defined a total of 12 tasks. You can see the task names and criteria in the table above, and visual examples are provided below. We then input the stitched grid image and the predefined task information into a multimodal large language model. This allows us to identify the object's name and determine the appropriate task to assign. Finally, we combine this task information with the previously obtained object segmentation entities to complete TUSMAP++. Therefore, TUSMAP++ contains comprehensive information for each object, including points, labels, and tasks. We established a new benchmark specifically for the evaluation of TUSMAP++. We recruited 32 annotators to establish the ground truth for appropriate tasks across all objects in 35 home environments. By leveraging this consensus-based approach, we were able to eliminate the bias present in the previous TUSMAP benchmark, which relied on a single annotator. We also propose a novel form of grounding problem, which we term context-aware grounding. From the perspective of human-robot interaction, humans tend to prefer indirect directives over direct directives when issuing commands to robots. Therefore, robots must be capable of identifying the correct object, whether dealing with an explicit query where the object name is clearly mentioned or an implicit query where the object is referred to implicitly. We present a method utilizing TUSMAP++ to address this context-aware grounding. The TUSMAP++ representation is converted into a JSON format via a map representation module. This structure includes the object's location, size, and assigned task. We then input this map representation and the context-aware query into an LLM to successfully ground the appropriate object. Now, let's examine the experimental results. First, here are the results for task assignment. On the right, you can see the qualitative results of TUSMAP++. Notice how it correctly assigns reorient to the fallen houseplant and wipe to the stained desk. Additionally, for the unnecessarily lit lamp, it assigned turn off, and for the fallen leaves, it assigned dispose. Consequently, we outperformed other baselines on the task assignment benchmark. Next, let's move on to context-aware grounding. Starting with explicit queries, when given the query, misplaced object on the floor, our method successfully identifies the misplaced state and selects the correct bowl. It also accurately locates the target for misaligned object. Finally, for implicit queries when the query is I hear water running, the model selects the faucet where water is currently flowing. Similarly, for the floor is sticky, it successfully identifies the spills on the floor. As demonstrated, our approach using TUSMAP++ effectively addresses context-aware grounding. We also conducted experiments in real-world environments. Let's look at the results. You can see that the model assigned fold to the crumpled cloth, mop to the liquid on the floor, and vacuum to the popcorn. This demonstrates that TUSMAP++ operates robustly, even in real-world scenarios. Thank you.